Hello, and welcome to Backer Breaks It Down. In today's episode, we are going to talk about something called radians. Okay, one of our objectives is that we want to distinguish between degree measure and radian measure. Okay, so we are very accustomed to measuring angles and arcs in terms of degrees. But there is also another way of measuring angles and arcs, and that is radians. So our little instructor over here said, I said a 3 pi right twist followed by a somersault and end with a 3 pi over 2 left twist. So this instructor is using radians. Okay, so check this out. Okay, so this applet to the right of the screen is illustrating to you what a radian is. What do you notice? What do you wonder? So that segment, that initial purple segment, is the radius of this circle. And so they're taking this purple segment and they're mapping it around and they're getting it to land right on the circle. So it's the same length. That arc length is the same length as the radius. So the radius and the arc length have exactly the same length to them, which means that slice that's being created is a radian. Okay. So what radians do is they make a connection between the actual measure of the angle and the radius of the circle. Okay. So if you need something more concrete, imagine a circle with a radius of 10 and an arc that's also 10 units long. That slice created, that's what 1 radian looks like. Okay. But that's the problem with angular measurements. I mean, we all know there are 360 degrees in a circle, but what relationship does those degrees have to the radius? They don't have a relationship. And so the radian allows us to give it that relationship. So 1 radian angle is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. Okay, so like I was saying earlier, imagine that this circle over here has a radius of 10. The arc length, I have such a specific slice of my circle that the arc length is also 10. And so I can say that this angle here has a measure of 1 radian. Okay, so I want you guys to be able to convert degrees into radians and vice versa. Okay, so let's see what the connection is. Right, so we know if you go totally around a circle, that's its circumference, right? Okay, and so I just got done telling you that a radian is equal to basically what you get when the radius and the arc length have the same measure. Okay, so basically if we were to take the entire circumference of our circle of 2 pi r and divide it by the radius, we would get the measure of that angle. And so they're saying the angle would be 2 pi, right? So basically, you go all the way around, we know that's 360, right? And so what this proves is that it's also 2 pi radians. So that's how they're directly related. 360 degrees is 2 pi radians, which means that 180 degrees would be pi radians, right? Yeah. And so when we convert from degrees and radians, we simply need to multiply by a conversion factor involving 180 and pi. Okay, So if I want to convert degrees into radians, I need to cancel out the degrees and introduce the radians. So that means I'm going to take theta in degrees, and I'm going to multiply it by pi to introduce those radians, divided by 180, because then the degrees will cancel out. Okay. To go from radians to degrees, I need to take theta, that's in radians, and I need to introduce the degrees, so that would be the 180 on top. And then I'm going to divide by pi because I have to get rid of the radians. Okay. But these are the two conversion factors for going from degrees to radians and radians to degrees. Right. Now, another little extra is arc length. So if the measure of your arc is given to you in radians, you can use this formula here. So the arc length is equal to r times theta. So it's a little bit simpler than the arc length for a degree, because degree was 2 pi r times theta over 360. So if you already do the math, or like if you're already starting with radians, you can instantly go to arc length by going radius times theta in radians. So like in number 1, they say find the length of the intercepted arc. They are giving us theta in radians. And so the rule is that S is equal to the radius times theta when theta is in radians. So the radius is 4, and then I'm just going to multiply that by pi over 2. And so when I do that, I get 4 pi over 2, which is simply 2 pi. So 2 pi would be the arc length, right? Problem 2 says a central angle theta in a circle of radius 6 inches intercepts an arc of length 15 inches. What is the radian measure? So I start with my formula. S for arc length is equal to r, the radius, times theta. And I write in what I know. Well, I know the arc length is 15, and I know the radius is 6. So in order for me to solve this for theta, I simply need to divide both sides by 6. Okay. And so 15 divided by 6 is 2.5, and this is equal to theta. And yes, that is in radians. So like a common misconception is that there must be a pi attached for it to be considered radians, and that's just not true. Okay, like what if they've already multiplied by pi? Like up above, like I could say it's 2 pi is the arc length, or I can say it's 6.28 approximately. So just because the pi isn't there doesn't mean like my answer isn't in like in terms of radians anymore. It's just they've already multiplied by pi, I guess. Okay, but pi is not like required for it to be in radians. Okay, especially like in a word problem like number 2 here. So I don't want you to get hung up on that. Got it? So going back to that whole business of converting, in 3 and 4, we want to go from degrees to radians, and we can go from degrees to radians simply by multiplying by pi over 180. Now you are expected to have fractions in simplest form, and so many of our calculators will simplify fractions for us. On the graphing calculators, like after you do like 150 over 180, you can go math, enter, and it will simplify the fraction. My little yellow calculators in my classroom, you can even type it in with the pi and it will handle it just fine. But you are expected to actually have an answer in simplest form. So at first it looks like we have like 150 over 180 times pi, and then when we reduce that, we get 5 pi over 6, and that would be my final answer for 150. So for 18 degrees, I'm going to multiply that by pi over 180. So at first, it'll be 18 over 180, and then there's a pi there. And then we simplify, and we simply get 1/10 pi, or pi over 10. When we go from radians to degrees, we're going to multiply by 180 over pi. That will get rid of the pi, and that will bring in the degrees. So the pi's would cancel out, and then I have 180 divided by 9, which is simply 20 degrees. So I'm multiplying by 180 over pi. That's how I'm getting the pi's to cancel. And then I'm just doing the resulting math. So in number 6, I'm going to go 76 times 180, and I get 210 degrees. So that is your little introduction into radians. You will definitely do more with this, like in Algebra 2 and pre-calc and beyond. Here, I want you to simply be able to convert between degrees and radians. So to go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. And that's how Backer breaks it down.